Hey, what's going on, everybody? Looks like we've been doing some work here and trying to figure out what was going on. When we were just tuned in, and it shows that we were having a little bit of, mechanical interlock. What it looks like the problem was here on this board here, on this DB25 board. This is where all our outputs go to the motors. But here's the thing: we have this connection, this parallel connection cord that we actually hardwired and actually set up the pin connection. I don't know if you can see inside there, and I'm gonna hold the light. This pin connection goes to the slip ring right there, where you see all those different colors. It goes to the slip ring. Well, here's the confusing thing: there's two blues. One is a dark blue and one is a light blue. So it looks like what we had to do, we had to check continuity by breaking the connection from the motors, which go to this DB25 circuit board, to this parallel board. What we did was we put a multimeter here and checked every pin connection. There's numbers on the inside of this connection where you can actually correlate with the terminal strip in the back. And with that terminal strip, you look at those numbers and it'll show you where to put your multimeter. So if you're on pin connection 1 here, you should be on terminal connection 1 in the back. And if you're checking continuity and you get to the point where you don't get continuity, then you that's how we narrow down the problem. Well, in doing our troubleshooting, we found that terminals 8 and 9 seem to be reversed. So what we've done now is reverse those two terminals back at the connector, and Roger can show you that in the back there.
Hold on a sec. You want to explain now why we had to break the connection here and why we couldn't test the terminal?
We had to break the connection because if we would have left this parallel cord connected to the DB25 circuit board and we tried to check continuity here in the board, what would have happened is we would have still continued to get continuity on those connection points because we've completed the circuit through the motors. So it's important not to leave this connected if you want to check continuity. You want to break the connection, therefore it becomes an open circuit. If you do not break the connection, the circuit isn't open, you won't get a true reading. So if you can go back to the back there, Roger will show you where he's reversed those two colors, and it's really hard to tell the difference between dark blue and light blue.
That's why you want to have good lighting.
And if you have to, get a wire tag.
And here's another thing: if you make the mistake and you decide that one is going to be the other, it really doesn't matter which one you use. It just has to be the same throughout the circuit. And if you get confused on that, then label it and make sure you check continuity. So if you decide that light blue is going to be 8, dark blue is going to be 9, it has to coordinate with your pin connection up front in the hub. So we've just switched those wires. Give us a second. We'll be right back. We're going to go ahead and do some more troubleshooting, and you'll see the finished product here in a minute.